Today we're going to look at some examples of Rolle's theorem and mean value theorem being used. Let's start with the Rolle's theorem. Rolle's theorem says what goes up must come down theorem. This is called what goes up must come down theorem. It sounds very confusing. If f of x is continuous on the closed interval ab and differentiable on the open interval ab, and f of a is equal to f of b, then there is a number c in the interval ab such that f prime of c is 0. In easy word, it says that if you have a function that has two equal y values at two different x values, then the function does have a point in there where derivative is 0. You do have a horizontal tangent somewhere in that interval. So and that's just, if you think about it, if two y values are equal, for example, if my y value at this point are equal, yes, my y values are equal at these 2 points, and my 2x values are different, y values are equal, then my function must come back for that to happen. So I do have a horizontal tangent somewhere in that point. Okay, so it seems confusing, but it says something very, very simple. If you have a continuous differentiable function on the interval ab and f of a and f of b are equal, then c lies in the interval ab such that the derivative at point c is 0. The function that went down must come up, only then the y value will be equal. Let's see some examples. Find the value of c satisfying the Rolle's theorem for the given function on the interval 0, 1. Okay, so we're given, so first of all, f of x is continuous on 0, 1. It is differentiable on 0, 1, open interval 0, 1. Differentiable on 0, 1, continuous on 0, 1. Also, f of 0 is equal to 2, and f of 1 is equal to 2 as well. 1 minus 3 plus 2 plus 2, 4, 5 minus 3 is 2 again. So my two y values are values are equal. Then there is a c in the interval 0 to 1 such that f prime of c is 0. The derivative at that point is 0. So let's go ahead and find the derivative. F prime of x is 3x squared minus 6x plus 2. F prime of x is 3x squared minus 6x plus 2. And we're looking for the derivative to equal 0. So f prime of c is equal to 0. That's what we want. So f prime of c is equal to 0. Okay, so set the derivative equal to 0. I'm going to say 3c squared minus 6c plus 2 equal to 0. 3c squared minus 6c plus 2 equal to 0. Let's go ahead and solve this. It doesn't look like it's factorable, so I'm going to go ahead and use the quadratic formula here. Negative b plus minus square root of b squared minus 4 times a times c divided by 2 times a. 6 plus minus square root of 36 minus 24 over 6. And using the calculator, here we get two values. So we'll get 6 plus root 12 over 6. So there's going to be two values, with one with the positive sign, one with the negative sign. Use the calculator, and we are looking between the interval 0 and 1. So we would be only using the positive value. 6 minus root 12 over 2, which is going to give me 0.42, and that's where we're at, 0.42. That's the value of c. So you get two values here using the calculator. One is using plus sign, one's using minus sign. We only want to give the value that's in the interval that we're looking for, 0 to 1. Another example, verify that the Rolle's theorem applies by checking f of a is equal to f of b in the given interval. Okay, again, Rolle's theorem only applies if the function f of x is continuous and differentiable in the interval, continuous from 3 to 5. So this function is continuous from 3 to 5. It is not continuous at 15 over 8, but that's not in the interval. F of x is differentiable between 3 to 5. That is correct. And let's check f of 3 here. That's 9 over 24 minus 15. 9 over 24 minus 15. That turns out to be 9 over 9, which is 1. And f of 5 is equal to 25 over 40 minus 15. 25 over 40 minus 15 is also 25 is equal to 1. So f of 3 is equal to f of 5. So using Rolle's theorem, there is a value c. Using Rolle's theorem, there is a c, a number c in the interval, from 3 to 5, such that f prime of c is 0. F prime of c is 0, and we're looking for the value of c. So let's go ahead and find the derivative really quick. What is the derivative here? If f prime of x would be, we're going to have to use the quotient rule here. Low d high, 8x minus 15 times derivative of higher term. Let me give myself more room to find the derivative. So we're looking for f prime of x. F prime of x would be, we'll have to use the quotient rule. Low d high, 8x minus 15 times derivative of higher term minus higher term times derivative of lower term, which is 8. Okay, so simplifying it, it turns out to be 16x squared minus 8x squared, which is going to be 8x squared minus 30x over 8x minus 15 squared. So now we're trying to figure out the point C or the point X, whatever you want to call it, a special point for which the derivative is 0. In the interval, we know there is a point. We're trying to figure that point out. So I'm going to say the derivative at point C is 0. So 8c squared minus 30c over 8c minus 15 equals 0, which gives me 8c squared minus 30c is equal to 0. And we can factor something out from here. We can pull out of 2c. Inside is 4c minus 15 equals 0. Either c is 0 or c is equal to 15 over 4. Now 0 is not in the interval, but 15 over 4 would be, 15 divided by 4 is like 3 point something, and that's going to be in the interval. So c is equal to 15 over 4. That's the value of c we were looking for in this case. Okay, let's see part B here. For part B, I'm going to erase part A. That way I have more room to do part B. Okay, part B. F of x is sine square x minus cos square x. First of all, f of x is continuous. This function is always continuous, so it doesn't matter which, because individual functions are continuous, that's why their combination function is also, their difference function is also continuous. It's always differentiable as well. There's no sharp corners. Differentiable on the open interval. There's no sharp corners. It's a smooth continuous curve. And also let us check f of pi over 4. What is f of pi over 4? Is sine pi over 4 squared minus cosine pi over 4 squared. Sine pi over 4 squared minus, that's root 2 over 2, and the both values are equal. F of 3 pi over 4. F of 3 pi over 4 is again root 2 over 2 squared minus root 2 over 2 squared. So we can plug in sine 3 pi over 4 squared minus cosine 3 pi over 4 squared. That is again 0. So f of A is equal to f of B. Thus Rolle's theorem applies. Rolle's theorem says that there is a c in the interval. There is a value x equals c in the interval pi over 4 to 3 pi over 4, such that f prime of c is equal to 0. Okay, so let's go ahead and find the derivative in this case. What's going to be the derivative here? And then we set the derivative equal to 0 to solve for the c. If you want, you can write it in terms of c, or you can just write it in terms of x. Okay, so the derivative would be f prime of x would be 2 sine x cos x minus 2 cos x sine x, right? 2 cos x sine x minus, that would be, this is sine 2x, 2 sine theta cos theta is sine 2 theta. So it's going to be 2 sine 2x. And we want to set the derivative equal to 0, or we can plug in the c if we want. It's probably easier to think about in terms of x. So f prime of x is equal to 0. 2 sine of 2x is equal to 0, which is going to happen when 2x is equal to pi and x is equal to pi over 2. And pi over 2 does lie in the interval, so that's the point we were looking for. So c is equal to, or x is equal to pi over 2. Another example, prove that f of x is equal to x cubed plus 3x squared plus 6x has precisely one root. So how are we going to prove that this has precisely one root? We will by contradiction. Using contradiction. Since we know that f of 0 is equal to 0. This function takes on the y value 0 at some point, because if I plug a 0 for x, then the y value is 0. Assume there is another x value such that another point x equals b such that f of b is equal to 0, because Rolle's theorem says that f of a and f of b has to be equal, and we already know f of x is smooth, continuous, and differentiable. Entire negative infinity to positive infinity, because it's a polynomial. Okay, so f of 0 is equal to 0, and we're saying there's another point such that f of b is equal to 0. So if that's the case, then there exists a point c in the interval 0 to b such that the derivative is 0. The derivative at that point, f prime of c, is equal to 0. Derivative f prime of c is equal to 0. Derivative is equal to 0. So now let's go ahead and find the derivative and see where are the points where the derivative is going to be 0. That's 3x squared plus 9x plus 6. Let's go ahead and see where is this derivative is equal to 0. We're going to try to solve it equal to 0. Let's go ahead and use the quadratic formula. As x equals, or c equals, negative 9. Well, it's going to be 6x. Not 9x here, 6x. Because 3 times 2 is 6. 3x squared plus 6x plus 6. When we do the quadratic formula, negative 6 plus minus square root of 36 minus 4ac. 4 times 6 is 24. 24 times 3 divided by, that's 72, divided by 6. Now, this is not going to have any real solution because I have imaginary in the denominator. I have a negative number in the denominator, in the square root. Negative number in the square root. I'm sorry, no denominator. Negative number in the square root. If we have negative number in the square root, there's no real solution. Thus, our assumption that we assumed is incorrect. Our assumption is not correct. That means this function f of x has only one root. It does not touch the x-axis again, only at x equals 0. The mean value theorem. For any differentiable function on a closed interval, there will be always a point in the interval where derivative of function equals the slope of line between the endpoints. Again, if you understand what the theorem is saying, it's not complicated at all. Okay. Intermediate value theorem said something else. Intermediate value theorem said, earlier we talked about intermediate value theorem. Intermediate value theorem said if the y values switch the sign, if y value goes from positive to negative, then you do have a point in there where the graph crosses the x-axis. Mean value theorem says that if you have a smooth continuous function, then, and you're all considering any 2 points on your function, then there is always a point on your curve in the interval where the slope of tangent line is equal to slope of the secant line passing through those 2 points. So if you have a smooth continuous function, you're considering 2 points. The average rate of change between 2 points will be equal to instantaneous rate of change at a point C in the interval. So the derivative at a point C in the interval would be equal to the slope passing through the 2 endpoints. Okay, let's see. So here is my function. My points are, I'm considering A and B. There is the slope of the secant line from, this is the secant line. Slope of the secant line would be equal to slope of the tangent line at a point C in the interval. So those two slopes will be equal. The tangent line and the secant line will be parallel in that interval. The point C lies in the interval AB. So here's what the statement of the theorem Theorem says if f of x is continuous on the interval ab and differentiable on the open interval ab, then there is a number c in the interval ab such that f prime of c is equal to f of b minus f of a over b minus a. In other words, the average rate of change between the endpoints is equal to instantaneous rate of change at a point in that interval. Let's see the use of the mean value theorem. Okay, find the value of c satisfying the conclusion of mean value theorem. So here's a function given to us and we're given the interval 0 to 2. First of all, mean value theorem only applies if the function is smooth, continuous, and differentiable. If your function is continuous and differentiable, only then we can use the mean value theorem. So we know f of x is continuous over 0 to 2. F of x is differentiable over open interval 0 to 2. And now we're saying the mean value theorem says f prime of c, mean value theorem applies, MVT applies, MVT says f prime of c is equal to f of b minus f of a over b minus a. In this case, your a is 0, b is 2. So there is a point in the interval 0 to 2 where the derivative is equal to slope of the line passing through the two endpoints. Okay, so let's go ahead and find out f of b minus f of a. F of b is, that would be f of 2 minus f of 1 over 2 minus 1. And the left hand side, we would have f prime of c. The f prime of x is 3x squared minus 2x minus 1. F prime of c would be 3c squared minus 2c minus 1. So simplifying it, 3c squared minus 2c minus 1. F of 2 is, if I go ahead and plug a 2 in here, what do I get? Plug a 2 would be 2 to the third power is 8. 8 minus 4 minus 2, so that would be 8 minus 4 minus 2 plus 1 minus 1 over 2 minus 0. This is going to be 2 minus 0. Okay, and that turns out to be, the right hand side will be 8 minus 4 is 4, 4 minus 2 is 2, 2 plus 1 is 3, 3 minus 1 is 2 over 2, which is 1. Okay, so now we're going to go ahead and solve it. Solve the equation. 3c squared minus 2c minus 1 equals 1. So we are going to bring everything to one side and factor it out if it's possible, or go ahead and use the quadratic formula. It's not going to be factorable. Negative b plus minus square root of b squared minus 4 times 2 is 8 times 3 is 24 over 2 times 3 is 6. So 2 plus minus square root of 28 over 6. Now out of these, which value is going to be considered, which value will be okay in the interval between 0 to 2? We are going to be going with the positive value because 1 will be out of the interval. So if you plug in 2 plus square root of 2 over 6 in the calculator, that turns out to be approximately 1.21. Approximately 1.21. So that's the value, 1.21. So think about f of 0 is here, f of 2 is here, and the theorem says that slope of this line is equal to slope of a line passing through at this point, which makes sense. They look like parallel if I'm going with exactly correct points. Okay, another example. Find a point C satisfying the conclusion of mean value theorem for y is equal to x natural log of x on the interval 1 and 2. First of all, we need to think about y is equal to x natural log of x. Is it a smooth continuous curve or not? So f of x equals x natural log of x is continuous on the interval 1 to 2. Close interval 1 to 2. It is differentiable over open interval 1 to 2. And that means MVT applies. Mean value theorem applies. Mean value theorem says f prime of c is equal to, there is a c in the interval 1 to 2 such that f prime of c is equal to f of 2 minus f of 1 over 2 minus 1. So f prime of c, what is the derivative y prime? Y prime would be x times 1 over x plus natural log of x, which is 1 plus natural log of x. So 1 plus natural log of c is equal to f of 2. If I go ahead and plug a 2 in here, what do I get? That turns out to be 2 natural log of 2 minus 1 natural log of 1, which is going to be 0. 1 natural log of 1 over 2 minus 1. 1 plus natural log of c is equal to 2 natural log of 2 minus 0 over 2 minus 1 is 1. So 1 plus natural log of c is equal to 2 natural log of 2. Natural log of c is equal to 2 natural log of 2 minus 1. And now we can go ahead and raise both sides to the power e. So x comes out to be, or the c comes out to be, whatever you want to call it, doesn't matter, e raised to the power 2 natural log of 2 minus 1. And from here we can simplify it, use a calculator, and we would be able to get the value of c, which is going to be approximately 1.47, approximately 1.47, which is in the interval. Corollary to the mean value theorem: if f prime of x for all x in some open interval I, if f prime of x is 0 for all x in the open interval I, and then the function is constant. If the derivative is 0 at every point, then the function is a constant function. The function doesn't go up and down.